Back for number 11, a stock's expected to pay a dividend of $2.50 at the end of the year, and constant growth rate is 9%, required return is 14%. I mean, they want to know the stock's price 5 years from now. So first we would need to find the stock's price today, and then we can move it forward 5 years. So first, I would find P sub 0, P naught, as d1 over r minus g. So 2.5 over 14% minus 9% is 0.05. So 2.5 over 0.05 is 50, would be today's price. And then 5 years from now, it'd be growing the price, the capital gains rate is supposed to be equal to G also. So 50 times 1 plus the growth rate, what, 1.09 per year. So 50 times 1.09, so to the 5th power with compounding, gets us to 76. And here we have no dividends paid for the first 2 years, and 3 years out, starts pays a $1 dividend with a growth rate of 15% per year in years 4 and 5, and then after year 5 growing at a constant 9%. So here's how I have this worked out. Required return is also 16%, which happens to be equal to the growth rate for those first 3 years. So that's why those first 3 terms of of our present value analysis are the same. End up with, which is 11.9. Okay, here we have number 12. Required rate of return is 17%. The stock has a dividend of $3.50 recently paid, and it's going to have growth rates of either, looks like, negative 7%, 0%, 6%, or 12%. Okay, so what is the value? The value would be, as you can see on the screen, I hope, the value is given as a d1 over r minus g. So the d1 is changing because of g, the growth rate. We have to calculate it. We have to calculate the next dividend using the growth rate, that is. And of course, g itself in the denominator is changing. So here's my calculations. When I do that, I get, let's see, for number 1 it was 13.56, 78, 40. Next, with part B, we have growth rate given as 15% now, and then 20%. Are these reasonable? Well, if the required return is 15%, that's R sub S, 15%. And the growth rate is also 15%. Then in that equation, d1 over r minus g would be 0. And if r were less than g, then that would give you a negative number. And as you know, stock prices cannot have negative prices. So most you can lose is what you've invested in the stock. So that number is limited at 0. So it makes no sense, and a negative stock price is a nonsensical. Anyway, okay, so it's nonsense. Why? Because the required return is less than the expected growth rate. That's why it makes no sense. Oh, okay. And then is it reasonable that a constant growth stock could have a growth rate greater than required return on stock? No, it's not really. Not reasonable. Not indefinitely anyway. Uh, okay, and here we have a dividend of 2.5 at the end of the year, D1. beta is given as 0.9, risk-free rate is 5.1, and market risk premium is given as 5. So we use CAPM to get the required return on this stock, and that gives us 9.6. And we plug that in for R sub S to our constant growth dividend model. D1 over R minus G turns out to be, well, we need the growth rate, G. So we rearrange that equation to get the growth rate equal to the total required return on the stock minus the dividend over the stock's price. So basically subtract the dividend yield and you're left with capital gain, which is what G is equal to, so 2.25%. But they're not asking for the growth rate, they're asking for the price in 3 years, which would be today's price times 1 plus the growth rate to the third power because it's 3 years. So 1.0255 cubed times 1.0225 cubed. But we need that growth rate to solve for the price in 3 years. So that the price in 3 years is today's price times 1 plus the growth rate to the third power. So that's $34, today's stock price, times 1.0225 cubed. And that gives us 36.35. 36.35.